Hello, my family. The term meteor is used to refer to any object in space that is larger than a speck of dust, but smaller than an asteroid. Based on this definition, around 4 billion meteors fall to Earth every day. Most of them, of course, are medium-sized rocks, and some burn up completely upon entering the atmosphere. Others, however, manage to penetrate the atmosphere and reach the Earth's surface. But what would happen if a meteor were to strike the Earth at the speed of light? Welcome to your channel, Unanswered Logic. This is a new episode all about what if a meteor hit the Earth at the speed of light. Let's take it step by step. Imagine a meteor made of an incredibly strong element, like diamond for example, with a diameter of just 30 meters. Now let's say it's heading toward Earth at 3,000 kilometers per second. That's just 1% the speed of light. In this case, the moment it enters the atmosphere, a violent reaction would occur, generating an immense amount of heat, comparable to that of a nuclear explosion. If the meteor manages to stay intact long enough to penetrate the atmosphere, it would hit Earth's surface with an energy over 1,000 times more powerful than the most destructive nuclear weapon ever detonated. The aftermath? It would be as if life had never existed in the impact zone. And remember, this is just from an object moving at 1% the speed of light. Now let's raise the stakes. If the meteor's speed increased to 99% the speed of light, the molecular bonds holding it together would completely break down. The meteor would disintegrate into a swarm of carbon atoms moving at incomprehensible speeds. And according to the laws of physics, the faster an object moves, the greater its kinetic energy. To understand what would happen next, imagine this. When we move our hands through the air moves around them. But at such insane speeds, air wouldn't just move around the carbon atoms, it would be forced inside them, getting trapped between the particles. This would cause the meteor's volume to expand dramatically, and by the time it reaches the ground, it would break apart again. But this time, because of its increased size, it would slam into the Earth with the force of 50 dinosaur-killing meteors combined. That's enough power to wipe out all life on the planet. Now let's go even further. At 99.99999% the speed of light, the energy in every carbon atom would skyrocket. The meteor's volume could swell to nearly 1,000 times the size of the Moon. Upon impact, it would tear open a massive crater in the Earth's mantle, shaking the entire planet violently, potentially melting the Earth from the inside out. But if we push the speed even further, to a level that matches the fastest speed ever observed for any particle with mass, one possible outcome is that the moment it touches Earth, a colossal plasma cloud would form. The explosion would release radiation and energetic particles across the globe, and in under 40 milliseconds, Earth's entire surface temperature would spike, producing a blinding light brighter than the sun itself. And that's if the planet still exists by then. And remember, we still haven't even reached 100% the speed of light. And here we've reached the end. We hope you found it informative and, more importantly, enjoyable. Don't forget to like the video and subscribe so we can keep bringing you content you love. See you next time and have a great day.